this is Rick Caswell with another example video. In today's video, I'm covering example 2 from section 7-6 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to graph a sine or a cosine function with all the little pieces in there, all right? Every stretch, compression, phase shift, vertical shift, whatever you want to see, crammed right on in here. Okay, so I want us to first look at the equation to make sure we know what we're going to be doing, and then we're going to deal with each of these, okay? Now notice on this one, our x, it ain't alone yet. It's not just a 1x. So the first thing I need to do is get this first equation to look like this, all right? So I'm just factoring out a 1/2. I'm going to call it 1/2 x plus 3. I also like to put some parentheses to make life easier. So there we go. All right, so if I'm thinking in terms of transformations, here's what's going to happen. So the 2 is a vertical stretch, right? Instead of going from 1 and -1, it goes to 2 and -2. All right, that 1/2 is talking about our phase. So our phase is 2 pi divided by 1/2. So our phase is 4 pi. So instead of it taking it out till 2 pi, it's now going to go out to 4 pi. So I'm probably going to need some more tick marks. This is why we plan ahead, okay? And then that plus 3, oh, why am I changing colors? So then that plus 3 is going to make everything go up by 3. All right, so there's our 3 numbers that are here, and that tells you our 3 things that we need to look at. So my first thing, I need to make sure my graph is long enough to go to 4 pi, because here I have pi over 2, pi, 3 pi over 2, 2 pi. I have 5 pi over 2, 3 pi. So I need 2 more tick marks. So don't mind me while I add those in there real quick. So there's 7 pi over 2 and 4 pi. There we go. Alrighty, so let's start. I taught you guys, I said, use some tokens. It'll make your life easier. And so that's actually what I'm going to do, is I'm going to use tokens to kind of model what we're doing here. Alright, so remember, our initial sine function looks like this. It goes between 1 and -1. There's some more numbers to help us to see it. Alright, now it goes on for forever. I'm just going to deal with these 5, and we'll add some stuff at the end to make it look right. And so I'm going to start from the left of this equation and move it to the right, just dealing with each of these values as I see them. You want to do translations last, I promise you. So we said that this 2 is increasing our minimum and maximum. It's a vertical stretch. So instead of this going to 1, it's going to go to 2. And instead of this going to -1, it goes down to -2. Okay, so we just stretched our graph out vertically a little bit. The ones that are already on the x-axis, when we talk about a vertical stretch, we're talking about the distance to the x-axis. So if we have points that are already sitting on that x-axis, we don't have to move them. Nice. Alrighty, so now we get to the 1/2. Now the 1/2 is a phase shift. I'm sorry, Lord help me, is a horizontal stretch. Okay, feels a little backwards too, doesn't it? It's because it's in that grouping symbol. So it's changing our phase to being 4 pi instead of 2 pi. So what we need to do is double the distance of each of these points from the y-axis. And so that's what I'm going to do, is I'm going to start with my middle points, and then I'll move these up and down points, right? So instead of being at 2 pi, this one goes to 4 pi. Instead of this one being just at pi, this one now goes to 2 pi. And this one needs to be in the middle, and this one needs to be in the middle. Okay, so that 1/2 stretched our graph out horizontally. Do you see that? That was just our change in phase. That's our B value, right? So I dealt with A, I dealt with B. Now I'm looking, is there a C? There's not, right? There's nothing being added or subtracted from X in the grouping symbol. Don't let yourself get confused on this original equation because there's no grouping symbols. Pop a grouping symbol around there if you need it to help you to see it. But that +3 is not part of the sign, or else they would have put a parentheses around it. Okay, so there's no phase shift, there's no horizontal translation. But this +3 is going to scoot everything up by 3. Alright, so I'm going to take every single anchor point and I'm going to slide it up by 3. So here's 1, 2, 3. This one's at 2, so it's going to go up by 3 to 5. Ooh, I was terrible drawing this graph. So 1, 2, 3. And it's okay if you label where this is at. Like if you label that's pi, comma, 5. That looks like a sad face. Let's get rid of that. There we go. You know, that might help you to remember later on when you're doing stuff. Alright, so this one goes from 2 pi up by 3. Now remember with sine functions, you'll always have, let's get rid of these extra anchor points. With these sine functions, you'll always have 3 dots in a row. And so that can help you with keeping stuff straightened out as well. So like this one at 4 pi's up at 3. Now this one's down at -2, so he's going to scoot up to 1. Again, there ain't no shame in writing out those ordered pairs. So this one's at 3 pi, comma 1. And then of course you want to draw in your curve. See why those tokens are nice? If you watched my last video, you'd be crying for these tokens right now. I tell you what. Alright, so now we're going to do that same thing. Let's talk about our cosine here. Alright, so in terms of the cosine, so that 2/3 is going to be a vertical compression, right? So instead of going all the way up to 1, it's only going to go to 2/3 of 1. So I'm going to adjust my axis here. And I cut those things into thirds. So the black mark is still 1 and -1 and 2. But now it has them thirds on there. That's going to be a real bear for us to keep track of. Like it's going to suck because our graph is kind of tiny. So just be aware. You want to make sure you know exactly where your numbers are, if that makes sense. Alrighty. Now this equation's already written in this form. There's just no b value. Our b is 1. Now this pi over 2, the minus pi over 2, that's a horizontal translation. Sorry, a phase shift. And because it says minus, it's going to go to the right pi over 2 units. And that +1 is a vertical translation. It's going to go up 1. Okay? So that's kind of the name of the game here. So in terms of our axis, I don't have much going on in terms of horizontal stretches or compressions. It's just moving to the right by pi over 2. So I don't need as many tick marks as I had up here. I just need an extra 1. Okay. So let's start with our anchor points. So this is a cosine graph. The cosine's almost like that funky V, right? So it starts at 1, goes to 0, goes to -1, goes to 0, goes to 1. Alrighty. So now we're going to do each part here. So first is our vertical compression to 2/3. So these anchor points are now scooting down to to be at the 2/3 marker and up to be at the negative 2/3 marker. Keep that kind of in your head. This is where I recommend labeling our points when we get to labeling them, okay? Because that's kind of hard to tell. Kind of hard to tell for sure. Alrighty. Next transformation, we move to the right by pi over 2. So notice my tick mark here, one tick mark is worth pi over 2. So each of these is just going to scoot over by one tick mark. Come on now. Alright, so there's our one tick mark over. And then it says plus 1, so translate up by 1. So now each of these is going to go up 1. So this one's at 2/3, so now it's going to be at 1 2/3. And we're going to label that or we're going to forget, y'all. So this is at pi over 2 and 1 2/3, or you can call it 5/3. This one just scoots up by 1, so that one's pretty easy. I'm still going to label it for the sake of people looking at this later. This one's at negative 2/3. So when it goes up by 1, it's actually going to pop up here to 1/3. So this anchor point is 3 pi over 2 and then 1/3. Oh yeah, that's why it's important to keep track of these. And to make sure that you draw nice big graphs. This one's kind of cramped, right, because it's on, I'm trying to fit it all onto here. But if you can, like, the bigger your graph, the better. I find that really makes life easy. And then this one again is already at 2/3 and it's going to pop up to 5/3. Alright, so we went through, we did our vertical compression, right? So we squished everything to 2/3 instead of 1 and negative 1. We went to the right by pi over 2, and then we went up by 1. And then we need to draw in our curve. Looks something like that. Now, when you guys do this on Savvas, I'm pretty sure Savvas just has you drag anchor points around. And it'll fill in the rest of the graph for you. But you could just follow that pattern, right? Like your next one would be down here at 1, actually, for that one. Right, so you would just follow that wave pattern. So there we have it, guys. That's how to graph a sine or cosine function. Until next time.